If you're confused about chapter 12, post in the forum and I'll hold an office hour for you. Now we're going to turn to a more mathematical side. The only difference here between this section and chapter 3 is that now we have a compound. So we have to add up the molar masses of the parts of that compound, all the elements in that compound. Let's take a look at water. How are we going to find the molar mass for water? We're looking for how many grams of water in 1 mole of water. We're going to use a periodic table. So we have basically 2 moles of hydrogen in that compound per 1 mole of water. 1 mole of hydrogen has 1.008 grams of hydrogen. So there's that molar mass we were just talking about. Right? This is from the periodic table. And then this 2 is from this compound. Then we're going to add, right, we also have 1 oxygen for every 1 water, and that's a number relationship. So that's 1 mole of oxygen for 1 mole of water. And then we have 1 mole of oxygen by itself is 16 grams of oxygen. So all this is a long way of saying 2 times 1.008 grams of hydrogen plus 16 grams of oxygen equals 18.016 grams of water in 1 mole of water. That's the molar mass for that compound. We added up those parts. So what this question is really asking is write conversion factors. There's our factor. And of course, because it's true for water, we could also say, okay, 1 mole of water must weigh 18 grams of water. So we can use that. Let's do the same thing for our calcium carbonate. Here we're looking for the number ratio of elements, the mole-mole ratio. So that I was really looking at just that first factor. So let's do that for the calcium carbonate. So I know for every, let's say I want to know how many moles of oxygen in 1 mole of calcium carbonate. I'm going to use that, that formula to write the value. I know there's 3 oxygen for every 1 calcium carbonate. So that is 1 factor. I could also ask, how many calcium are there? How many moles of calcium in 1 mole of calcium carbonate? So again, I'm just going to use that number in the formula. That's a 1 mole of calcium. Okay, so down below this is where I was referring back to chapter 3.6. We were using the atomic mass, now we're adding them together like I showed for water to calculate the molar mass. So water I have shown above. 1 mole of water weighs 18 grams, or 18 grams of water must be 1 mole. So that's 6.022 times 10 to the 23rd water molecules. Go ahead, let's calculate it for calcium carbonate. I think we're back on track here. I'm going to look up calcium on the periodic table. And I've got 3 oxygens, so I'm going to add those all together. Now all together, that's going to be grams of CaCO3 in 1 mole. And I did that on purpose, right? I used 1 calcium. I used the grams per mole of calcium. So you can see up at the top how the way I've done it down here in the shorthand notation could be expanded in dimensional analysis to show those relationships. You might see it written like this: 100.09 grams per mole calcium carbonate. They have the same label, so that really means 100.09 grams of calcium carbonate on top and 1 mole calcium carbonate on the bottom. So sometimes we see that slanty line. It's good in your own work if you keep it really flat, keep it a horizontal line. So you can see a clear top and a clear bottom. Okay, now we're going to put it together. So using dimensional analysis, we're going to write the units of our final answer with a question mark and the label. We're going to write the given information, and then we're going to figure out what relationships will make that change for us, will complete the conversion. How many grams of oxygen, how many grams of O equals 25.0 grams of calcium carbonate? We've got this relationship down here. And then we've got all of the relationships from the formula. Oh, there they are. They're up here. The first thing we see is that grams of calcium carbonate does not appear in the answer, so it has to get canceled out. So first thing we have to do is get rid of that unit by doing what? Okay, so we're going to use these factors here, right? We've just got those factors we're going to line up. We're going to use this answer, which I rewrote like this. Where does the number go? I'm going to fill in the units first. So 1 mole of calcium carbonate must weigh 100 grams. So now I know the 100 has to go in front of the grams. So the units tell me it's not multiply, it's divide. All right, now I'm going to get moles of calcium carbonate down here. And when you don't know what to do, we're going to go to moles. We're going to use moles to change the label. So now the units are the same, and I'm going to change the labels. I'm going to go from calcium carbonate to what I'm looking for. I'm looking for oxygen. So then we have to go fill in the numbers. So I'm leading by canceling out the moles of calcium carbonate and then saying, how do I get closer to my answer? Well, next we're going to change the label. The 3 goes on top with the oxygen, and it comes from the formula right here. 3 oxygen for 1 calcium carbonate. Now the moles are oxygen. We don't see moles in the answer, so I'm going to put moles of oxygen in the denominator, but we're looking for grams of oxygen, and we know that. So I'm going to put that on top and fill out values. So 1 mole of oxygen is 16 grams, and I get that from the periodic table. And now I have grams of oxygen equals grams of oxygen, so I know I'm done. That tells me what to do with the numbers. I like to just, I'm going to go 25 divide by 100 times 3 times 16. So what I did here was I went from grams of one thing to moles of that thing. Then I changed the label, went to moles of something else, and then I went to grams of that other thing. So it always goes grams to moles, moles to moles, moles to grams. Oh, look, it's exactly what I have next. Mass to moles, moles to moles, moles to mass. You can never go straight from grams of one thing to grams of the other. All right, so we're going to write the conversion. What goes here? What goes here? What goes here? So if we want to get moles of A, I'm going to cancel out grams of A and 1 mole of A. And now I'm in A. On this one, I'm going to go from moles of A to moles of B. That's a mole-mole relationship. And then on this one, I'm going to go from moles of B to grams of B. So notice When the units match, you change the labels, and that's going to be your mole-mole relationship. Our factors are going to be a molar mass or a mole ratio. In this case, it's from the chemical formula, but we're going to find out that we can get those from balanced reactions as well. All right, so let's get started here. How many grams of calcium carbonate? Oh, and let's change this. 1,000 milligrams drives me crazy. This is 1.000 grams. So when you buy your tablets, it'll say 1,000 milligrams because all the vitamins are in milligrams usually. But 1,000 milligrams, this is 1,000 times 10 to the minus 3 grams. We're trying to eat, we want to eat 1 gram. So if you're trying to get all your calcium from your calcium carbonate, how much of it do you have to eat? So go ahead and apply this. Mass to moles, moles to moles, moles to mass. 1,000 milligrams, and that equals 1.00 grams. So mass to moles of calcium. Next, we're going to go from moles to moles. So we start with calcium. What are we looking for? Look on your answer side because you wrote it down. That's your guide. That's what you can look at to see what am I doing here. Okay, I need calcium carbonate on the top, so that must be a mole-mole relationship. Now fill in the numbers. For every one of these, there's one of those. Okay, great. Go ahead and write it. I know it seems trivial because it's 1, but go ahead and write it because it will guide you through the calculations. And if you get frozen, if you don't know what to do, you'll look at your paper and it says, this is what to do. Moles of calcium carbonate are not in the answer. But again, I look at the answer, I want grams of calcium carbonate on top. So I think about what do I know? I know that 1 mole there is 100.09 grams because we just calculated it. Then the moles of calcium carbonate are gone. The only thing left for our units is grams of calcium carbonate, and that's what we're looking for. So that's how we know it's done. So it's almost 2.5 grams. Calcium carbonate is like the Tums, those pills. So to eat 2 grams of those, you have to eat like 4 or 5, I think. Okay, let's do it again. Magnetite. This is magnetite, is the Fe3O4. Because it's all multiplication division, they all go by significant figures. So this one has 4 significant figures, 4, and this one has 5, which is great. So this ends up with 4 significant figures. And we could round it 2.497 grams calcium carbonate. All right, so let's get this laid out. How many grams of iron? How many grams of Fe can we get starting with, this is 1,500 of Fe3O4, and that's actually just 2 significant figures. So follow that same pattern. Here we're going to need the molar mass, right? We need to go to moles. 1 mole of Fe3O4, we need to figure out that value. So for that, we're going to take 3 iron plus 4 oxygen. We're going to plug in that number. So we're at the end of our time, so I think we just have one more page. Blah, blah, blah. We're going to go back to percents. So take a look at this. When you finish Chapter 6, Part 1, I'd like you to try and work ahead. get through chapter 6, part 2. I have extra time for you because it's very mathematical. So if you can try and get ahead on that,
Hmm.
this is not on the quiz, but that Alex assignment will help you practice. And if you can get a jump on it, that'll be really helpful. It's always the same. It's the mass to moles, moles to moles, moles to mass. So
Hmm.
I remember when I took this class and my boyfriend could do it. He knew what to do and I had no idea. And I just thought,
Hmm.
this is impossible. How
Right.
does he know? This is impossible. And only 6 months later, I went to college and I was like, hey, it's not impossible. I can do this. So I know that feeling like this is really challenging to start with because it's all new. But once you get some time, then it begins to make sense. So all it
Hmm.
really is, the only difference is practice.
Okay.
I would love to share with you the gizmo, geometry gizmo. So that's a really good way to just do problems and see how it fits together. And then there's videos. Let me go to our video resources. It's right at the second post of the course. So Crash Course is very quick. He talks really fast and it's fun and exciting. So I didn't link all of the videos, but they he lists them on the side and you can pick your topic. They're like 10 minutes each. And then
Okay.
Professor Dave, he explains a little bit more, but they're still like 10 or 15 minutes each. And
Hmm.
he uses a lot of graphics and explains how to solve it. And organic chemistry has like 45-minute videos where he takes you through everything. And
Hmm.
very good. Organic Chem Tutor is really thorough and correct explanations. So if you want to learn, you're like, I have no idea, let me start from the beginning. Organic Chemistry Tutor might have some good stuff for you. Khan Academy also has good videos, but most of his chemistry he did a long time ago. And
Hmm.
they are slow. They're like my lectures, like really slow. And now in video education, they want to go fast and give you graphics, and you can stop the video if you need more time. So Khan Academy
Okay.
is not as engaging.